Hi, I'm Tom Dick. I'm a math professor and a math advisor for Texas Instruments. This short video is part of the TI-Nspire AP Calculus series. Here we're going to take a look at how you can use lists and spreadsheets on the TI-Nspire to investigate tabular data in calculus. The example we're going to use to illustrate this is some data that comes from the Common Question 4 on both the AB and BC exams in 2018. Now, I've gone to a Lists and Spreadsheets page, and I'm going to enter the data that was given in the problem. For column A, I'm labeling that T data for time data. And the data that was given to us in the problem was the time in years at which the height of a tree was recorded. Those times were at 2, 3, 5, 7, and 10. Now I'm going to go up to column B, and I'm going to label that column H data for height data. So these will be the heights of the tree measured in meters, recorded at each of those times. So at time equal 2, it was 1.5 meters tall. Time equal 3, it was 2 meters tall. At 5, 6. At time 7, 11. And at time 10, the tree was 15 meters tall. So now we have all of the data that was given to us in the problem. Now, before going any further, I'd like to get a visual look at this data by doing a scatter plot. So I've gone to a graphs page, and it's set up for function plot now. We're going to want to change that by going to the graph entry menu, and we're going to go down and do a scatter plot instead. We're prompted to enter our independent and dependent variable data. For our independent variable data x, I'm going to choose t data. That's our time data. And then for our dependent variable y, I'm going to choose our height data, or h data. Now, I've done a scatter plot, and I'd already set up the window so it would accommodate this set of data values pretty well. Let me move that label a little bit out of the way. Now, I want to connect these data points. So I'll go to the Actions menu, choose Attributes, and then when I point to my scatter plot, it's going to allow me to change some of the appearance of the graph. I could change how the points look. I want to go down to the second set of options, which is going to allow me to choose to connect the points, which I'm doing here. And now we have this nice connected scatter plot, and you can think of that as a piecewise linear approximation to the function describing this data. Now, if I wanted to trace, we can just turn on the trace, and what this is going to do is jump from data point to data point. There we can see time equals 2, height of 1.5, and we can jump to each of the 5 data points that we have represented in our data table. Now, one of the questions that were asked in this problem was to approximate h prime of 6. The derivative of h at time t equals 6. Now, t equals 6 is not one of our data values for time, but a calculation of the slope of the line segment connecting the nearest data points to the left and right of t equals 6 would be a good approximation. So I'm going to a calculator page. I'm going to calculate that slope. That's going to be the difference in our h values, 11 minus 6, divided by the difference in the time values, 7 minus 5. This is called a difference quotient. Now, the units of measurement on this quantity are meters per year. And this difference quotient has given us an approximation of the rate of growth of the tree in meters per year at time t equals 6 years. Okay, let's go back to our graph. And the next thing we were being asked in this problem was to use a trapezoidal sum to approximate the average height of the tree over the time interval from t equals 2 to t equals 10. Now I'm going to the geometry menu, and I'm going to choose line segment to add a few features here to help us visualize what we're actually calculating here. So I'm adding a little vertical line segment up to each data point from the x-axis. And that just makes it much more clear that the integral of this piecewise linear function, which is really what a trapezoidal sum is a sum of trapezoidal areas. Each one of those trapezoids areas would be calculated by taking the average of the heights at the two ends times the width of that interval that it sets on its base. And that's just a formula from geometry for areas of trapezoids. Okay, let's go back to our lists and spreadsheets and actually do these calculations using the spreadsheet feature that were provided here. Okay, so we have all our time data and height data. And in column C, I'm going to calculate the area of that first trapezoid. So I'm going to need to find the average of the two heights. And that will be the average of 1.5 and 2. So I'll add 1.5 plus 2. And what I'm going to do is use cell references here. So I'm going to take B1 plus B2, those two cell values, divide by 2. And that'll be the average of those first two heights. And then I'm going to take that times the width of that subinterval, which would be A2 minus A1. Again, I'm using cell references here. So that'll be my 3 minus 2 that I see in those two cells. Enter that, and that gives me the average of the two heights times the width of the subinterval, 1.75. Now there's that formula, all in terms of those cell references. And the reason that I took the trouble to do that is what's nice about a spreadsheet is I can now select that cell and drag down, and what it will do is mimic that formula for each of the other trapezoids. Now that we have the areas of those four trapezoids, let's go ahead and use this next available cell, C5, and what we'll do is calculate the sum of the four of them. So I'm writing equals sum, and I'm actually going to use the format that most spreadsheets use. I'm going to enter the run of cells that I'd like to sum up. So that's from C1 to C4, and we indicate that with a colon. So C1 colon C4. And then when I complete that formula and hit enter, that gives me the sum of the four trapezoids. Now that trapezoidal sum, remember, we're really after the average height of the tree. So I need to take that sum and divide by the length of the total interval. So I'm going to still do this in cell references. So C5, and divide by the difference of my last time value, which is an A5, and my first time value, which is an A1. So I'm dividing by A5 minus A1, and there's my average height of the tree, 8.21875 meters. Well, that concludes this video. For more calculus resources like these, please see education.ti.com.